Hey guys, Mrs. Ann here. On activity sheet 1, we talked about that there's not just the method of graphing systems and that we can use what we call two other algebraic methods. And we're going to talk about the first one, substitution, today. So let's take a look at this example problem. Desmond wants to pay Andrea $5 more an hour than he pays Max. Desmond has a budget of $250. He has decided that Andrea will work 10 hours, Max will work 15 hours. Created a system to show Andrea's hourly rate and Max's hourly rate. So Andrea gets A, Max gets M. So let's talk about this first line here. Andrea is going to get paid $5 more an hour than Max. So that comes up as Andrea gets paid $5 plus Max's wage. Okay. My second equation is going to go off of the budget of $250 and that Andrea is going to work 10 hours and Max is going to work 15. So we're going to say 10 hours times Andrea's rate plus 15 hours times Max's rate will equal $250. So that was our equations. Now they want us to solve this system. Okay. Now, solving a system, guys, this means when we're using substitution, when one variable is isolated, we want to use substitution, and we're going to substitute its value into the other equation. What that means here, A equals, there's our one variable isolated. We are going to take what A equals and substitute it into the other A in the second equation. Okay, it's like football. If you take out your quarterback, if your quarterback gets injured, you're going to substitute in another quarterback. Okay, this A is injured. He's going on the injured list. We are going to take another A that's equal to it, that does the same thing, and substitute it in. So instead of putting an A, we're going to say what A equaled, 5 plus M. Okay, so I'm going to go through, we're going to solve that, and when we do, we get that M equals 8. What does that mean? Mark makes $8 per hour. Okay, they want to know what substitution was made here. Okay, what we did was we took the first equation, A equals M plus 5. M plus 5 was substituted into the A in the second equation. Question C, after this substitution was made, how many variables were left? Well, let's take a look. When I substituted in 1M and an M, only one variable was left. We eliminated the A and we're left with the M so that we could solve. Okay, let's go on to question 3. In this solution, the value M, 8, was substituted into the equation A equals M plus 5 to find the value of A. They want us to verify that we get the same solution if you instead substitute it into the other. What they're saying here, guys, is they want you to take our answer. We said that M equaled 8 and plug it into both of these equations to make sure that it holds true. Okay, so when I plug this into this first equation, I see that, make sure you matching it here. M is 8, so I'm going to replace that M with an 8, and I get that A equals 13. I'm going to use this one now. A equals M plus 8. M plus 5, and we get 13. It's true for both, so we know it's true. Andrea makes $13 per hour. Okay, in question 4, we're going to go through and just double check. Plug our A is 13 and M is 8 into each equation. 13 equals 8 plus 5. We get 13 equals 13. It's true, it works. Over here, if we plug that 13 and the 8 into the respective variables, we get 250 equals 250. It's true, therefore it is a solution. Our steps for when we're solving systems of equations using substitution, okay, using the substitution method, we're going to solve one equation for a variable. That simply means rearrange it so one equation has one variable isolated. This is like our A equals M plus 5. This A is isolated. That's what we want. If it's not, we have to do it. Step 2, substitute that expression into the other expression. Step 3 is solve. Step 4, get your answer and substitute that into one of your original equations. And then step 5 is always, always, always check your solutions. Okay. Questions 6 and 7, 8, 9, and 10 are going to be done, and 11 are going to be done. No, let's go back to question 11. Okay. So let's just look at these. Which of these equations would we want to use substitution for? Remember the first thing I told you, in order to use substitution, guys, we want at least one equation to have a letter equals. One letter has to be by itself. So when I look at this, I see that right here. So would we use substitution? Yes, absolutely. Why? Because one variable is isolated. Looking at this one, would I use substitution? No variable is isolated. However, if you look at this first equation, it would be pretty simple to get that by itself. All we'd have to do is say minus 5y on the other side, and we would have that x equals 4 minus 5y. So would it be my first choice? No. However, was it easy to do? Yes. So I'm going to go ahead and say, yes, we would use substitution. Why? Because it was easy to isolate a variable. It was quick. We like quick, right? You guys all want the short steps. When I look at this, guys, neither one of those equations has a variable by itself, and neither one of them could be done in one step. So no, I'm not going to use substitution here. Okay. Why? Because no variable is isolated. Okay. Let's go on. Question 12. Use the substitution method to solve. So bear with me here, guys. First thing I'm going to check for, I have a variable by itself. Great. Step 2, substitute what that variable equals. So it equals 2x minus 10 into the game, into the other variable. So with this, that second line is going to say 2x minus 5 times my y equals 18. Well, what did we just say y is going to be? 2x minus 10. And we're going to go ahead and solve that. Okay, I'm going to distribute to get 2x minus 10x plus 50 equals 18. Combine, negative 8x plus 50 equals 18. Subtract 50 on both sides. Negative 8x equals negative 32. Divide both sides by negative 8, and we get that x equals positive 4. Now, remember, guys, we're not done. We have not finished. We only have x. We've got to figure out what y equals. Well, guess what, guys? I don't know about you, but I want to take the equation that says y equals. If I'm going to solve for the y, use that one. So I'm going to say y equals 2 times my x value, which we just solved for and said it was 4, minus 10. So y equals 8 minus 10. Y equals negative 2. Okay. Agile Minds doesn't require you to write them as an ordered pair, but these are points. This is a point where they cross the line. We write them as x comma y. So I'm going to write this answer as 4 comma negative 2. Number 13. When I go to solve this one, how would I solve it? Well, when I look, neither one of them has a variable by itself. We need to get the x alone. Isolate the x in the first equation. Okay, so I'm going to go ahead and do that. All I have to do is minus that 5y to the other side. So my two equations are going to be x equals 4 minus 5y, and my second equation stayed the same. Okay, so part B wants us to now solve it. So I'm going to rewrite this again so you can see it. X equals 4 minus 5y, and 3x plus 10y equals 10. Okay, so we have what x equals. Here's what x equals. Substitute it into the other x. 3 times my x plus 10y equals 10. We said that x is 4 minus 5y. So let's go ahead and solve this problem out. We're going to say 12 minus 15y plus 10y equals 10. Combine 12 minus 5y equals 10. Subtract 12 on both sides. And we get that negative 5y equals negative 2. Divide both sides by negative 5. This is those ugly answers we were talking about, guys. Y equals positive 2 over 5. Okay. And if we rewrote that as a decimal, you could always call that 0.4. Okay. For some of you guys, it may be easier to work in decimal form on this next part. Okay. Now, let me just double check that they don't want us to do this on part C. Okay. And with this one, now we have to go back. I'm going to use the original equation. X equals 4 minus 5 times my y. Well, we just said y was 0.4. So I'm going to use my calculator on this, and I'm going to say 4 minus 5 times 0.4 equals 2. Okay, guys, I didn't do that math on my own. Calculator did it. Okay, so my answer here, again, you can use either one of those. I'm going to say my x is 2, my y is 0.4. Now, with this one, guys, both of these are y equals. Now, normally we'd say, hey, they're both in slope-intercept form, graph them. Look at these intercepts, though. I'm not graphing something that has an intercept of 160 or 400, okay? So this is why we want to use the substitution method, okay? Substitution. So here, we have what y equals. We're going to substitute it into the other y. I like them when they're like this because we just have to set them equal to each other. So we're going to say 45x plus 160, and again, I'm just rewriting the second line, equals 15x plus 400. And I'm going to go ahead and solve this. Letters to the left, numbers to the right. I'm going to do this all on one step here. And I get that 30x equals 240. Okay, last step, divide both sides by 30, and we get that x equals 8. Go back and solve for y. You can use either one, guys. Does not matter which equation. I'm just going to use the top one, 45x, so 45 times 8 plus 160. Again, I'm going to plug that right into my calculator. 45 times 8 plus 160 equals 520. Those two lines would intersect at the point 8, 5, 20. Okay. When might we use substitution for solving systems? When we got crazy numbers like this, guys. We don't want to be graphing those. Okay. And from here on out, guys, you are doing these with your teacher in class. Have a great day.